rotational dynamics, and it is kinetic energy of rolling body. So in previous class, we already learned kinetic energy of rotating body, and kinetic energy of rotating body we get 1 by 2 I omega square. So this is for rotating body. Now we have to find out if the body is rolling, then how much is the kinetic energy. Basically, for that we consider body of mass m, radius r. It is rolling on inclined plane with angle inclination theta and height h. Then you can see this body in a diagram. Initially this body having a zero velocity. We release this body. So when this body is coming down, so this body is moving in a straight line motion. It means that this body having a translational kinetic energy. As well as it is coming down, so that time it is rotating also. It has a rotational kinetic energy also. So this rolling body having two kinetic energy. First one is translational kinetic energy, means straight line kinetic energy, and it is rotating also. So it has a rotational kinetic energy also. So we can write total kinetic energy is by this formula. Total kinetic energy is translational kinetic energy plus rotational kinetic energy. Now translational kinetic energy we already know, 1 by 2 mv square, mass into velocity square. And rotational kinetic energy we already derived, half I omega square. I is the moment of inertia and omega is the angular velocity. Now after that, we have to use here the relation between linear and angular velocity. We know that V is equal to R omega. So by using that, as well as we know the I is equal to mk square. So V is R omega. So I can write here omega is equal to V by R. Omega is V by R. Okay, you can see here omega is V by R. So omega square you get V square by R square you will get, because omega square we have to substitute in a equation, omega square and I. So this omega square and this I both we substitute in this equation, then what we get, you can see here. So we get an equation for kinetic energy, half mv square plus half mk square. Mk square means this is I we substitute, and this V by R square, bracket square basically, or we can write V square by R square by simplifying bracket also. Now after that, we can take a common. What is common in this? Half is common, m is common, V square is common in every term. Half mv square we are taken common. So as I take half mv square common, so in a bracket I get 1 plus k square by R square. And this is expression for rolling kinetic energy. You remember this, rolling kinetic energy and rotating kinetic energy is different. This question is already asked in the board exam, so very important.